Welcome to the debate. Right now, a student with, absolutely zero coding experience can use AI to build a fully automated software company in a single afternoon.
Yeah, which is pretty wild to think about.
It is wild. But here is the reality. 90% of those students are going to watch their intricate systems completely collapse within a week.
Oh, easily. Maybe even less than a week.
Right. And why does that happen? Because the methodology we use to teach this technology is fundamentally fractured. So today, we are analyzing a critical pedagogical question from the current methodologies of AI deployment.
Which really comes down to the starting point. When we are explaining this core concept to students who are looking to build their very first automation projects, what is the correct way to begin?
Exactly. Is the foundational concept of automation best understood as a micro-level mechanism, focusing on task efficiency and workflow optimization?
Or conversely, should it be taught as a macro-level engine for scalable systems and recurring value generation?
Now, I represent the perspective that the conceptual starting point absolutely must be mastering rule-based task elimination. Students have to learn this through a strict, isolated, trigger process action framework.
And I argue that reducing AI automation to just a slightly faster way of completing digital chores completely misunderstands the leverage this technology actually offers.
I wouldn't call it just a faster way of doing chores, but go on.
I mean, it is. The core concept students must grasp from day one is systems thinking aimed at passive value creation. We are really contrasting practical workflow guides with passive income system architectures here. And frankly, I believe starting small is exactly how you kill a student's momentum.
Well, let's examine what starting small actually means in this context, because I view it as grounding the student in architectural reality.
Architectural reality?
Yes, reality. The source material emphasizes a very specific strategy for beginners, right? Identifying daily, rule-based tasks.
Sure, the basic chores.
Think about things like summarizing meeting notes, triaging a chaotic inbox, or drafting weekly status updates. The student takes just one of those tasks and learns the fundamental mechanics of connecting an input to an output.
Right, but
Let me just finish this thought. They learn what a trigger is, they learn how to pass data to an AI model for processing, and then how to route that output to a final action. It's foundational, it is low risk, and it teaches the underlying logic of the technology without completely overwhelming the builder.
okay, but look at the mindset that establishes. If you tell a student that AI is just a tool to, shave 10 minutes off their Friday reporting, you are doing a massive disservice to the technology's actual potential.
How so? It's practical.
Because you are training them to think like an employee trying to get off the clock early, rather than an architect building an independent asset.
I think that's a bit of an exaggeration.
Not at all. The true concept of AI automation today is building an engine that delivers recurring value with minimal ongoing effort, whether that is an automated content site, an AI-generated digital product pipeline, or a micro SaaS tool. The first project should focus on scalable outputs.
But
The goal isn't saving a few minutes of manual labor. The goal is creating an asset that operates independently of the student's time entirely.
the problem with starting a beginner on a macro system like that is that you are asking them to build the electrical grid before they even know how to wire a single outlet.
I wouldn't say it's the grid. It's just a bigger house.
No, it is the grid. Let's look at the actual mechanics of a basic task automation. Say a student wants to turn raw otter.ai transcriptions into project management tasks.
Which is a highly useful feature, sure, but still just a feature.
Exactly. But look at the sheer complexity hidden inside that single feature. The trigger is a meeting ending, a payload of totally unstructured text is generated.
Right.
The student has to use an automation platform like Make or Zapier to catch that data and send it to a large language model, and here's where the fundamental lesson actually occurs. They learn the friction between deterministic systems and probabilistic models.
Well, everyone learns that eventually.
But they need to learn it early. The API of their project management tool is deterministic. It requires data perfectly formatted, usually in strict JSON, to create those task cards. But the LLM is a probabilistic text generator. It just predicts the next token.
Which is why you have to prompt it correctly.
But what happens when they don't? If the AI decides to be helpful and prefaces its output with, "Here are your tasks for the day," before outputting the JSON, the entire payload is rejected by the API. The automation completely crashes.
Sure.
If a student doesn't understand that basic fragility on a single, isolated task, how can they possibly build an automated content site?
See, you're highlighting the exact reason why isolated microtasks are a conceptual dead end.
A dead end.
Yes, yes, the deterministic API and the probabilistic LLM constantly clash. Anyone listening to this who has tried to map variables in Make knows exactly how frustrating it is when the AI goes rogue and breaks the mapping.
Exactly my point. It's frustrating.
But if the student is only trying to save 10 minutes summarizing a meeting, the moment that JSON payload fails, they will just abandon the project. They'll just go back to writing the summary manually. The friction of debugging outweighs the reward.
So you're saying the complexity requires a bigger payoff to justify the effort?
Precisely. Now, place that exact same technical challenge inside a system designed to generate reoccurring value. Let's look at the content-driven ecosystems from the source material.
Okay, let's look at them.
A student decides to build a niche site around budget travel in Southeast Asia. You aren't just hooking up one API, you are triggering a weekly script that scrapes trending topics.
Which is already prone to breaking.
That data is fed into a reasoning model to select the best keyword. That keyword triggers a research agent that pulls live search results. Those results are fed into a writing model tightly constrained for SEO, which generates HTML, inserts affiliate tags, and pushes directly to a WordPress REST API.
That is an entirely autonomous content factory,
Yes.
which is a complete house of cards for a beginner. If step 1 hallucinates, step 4 multiplies the error exponentially.
It is complex, yes, but the motivation to learn those technical steps only exists if the end goal is a system.
I disagree. The motivation is learning the tool.
If I'm a student, I will gladly spend 5 hours debugging an API payload or learning how to enforce JSON mode on a language model if I know it is the bottleneck in my passive income engine. I am not going to spend 5 hours debugging a payload just so I don't have to copy-paste my meeting notes.
Okay.
The macro-level goal drives the micro-level mastery.
I understand the motivational argument, I really do. But it completely skips a crucial developmental phase: testing, failure, and predictability.
You test macro systems too.
But not in the same way. Let's dive into what prompt engineering actually looks like in practice. When you build micro workflows, the testing phase is intensely manual and highly controlled. You have to write a system prompt with severe constraints.
Right.
You don't just test the happy path. You have to inject chaotic inputs to see how the system handles edge cases. If I am automating a client intake process, what happens if the client sends an email entirely in Spanish?
The AI translates it.
If you prompted it to, what if it's just an angry one-line complaint? What if it contains a massive, poorly formatted PDF attachment?
So you're talking about testing the linguistic predictability and edge case handling of the model.
Yes, exactly. You are tuning the prompt and the conditional routing so that the AI behaves predictably before you ever let it run automatically in the background.
I agree predictability is important, but
Let me just frame it this way. Traditional automation, the pre-LLM era, was like laying down train tracks. The data could only go exactly where the tracks went. It was rigid but perfectly predictable.
right, and it was just if-then logic.
But AI automation gives that train a steering wheel and a destination, and it decides its own route every single time it runs. That is incredibly powerful, but it means the system can drive right off a cliff if you haven't mastered the constraints. That is the most vital lesson a beginner can learn.
Look, that is a compelling way to frame the unpredictability of AI. I'll give you that. But by focusing entirely on linguistic predictability, you are ignoring the most important feedback loop in a real-world system:
Which is?
market feedback. In a macro approach, testing isn't just about whether the AI followed your character limit or outputted clean code. It is about whether the system you built actually survives contact with the market.
But market feedback is completely irrelevant if the system is technically broken.
Not necessarily. Let's go back to the digital products example from the material. A student builds an AI-generated Notion template business.
Okay.
The AI generated the template structure, it wrote the marketing copy, and it automated the delivery sequence on a platform like Gumroad. When we say testing in a macro system, we are talking about multivariate market feedback.
So looking at dashboards and metrics. Exactly. The student has to monitor the open rates of those AI-generated emails. They have to look at the conversion rate on the landing page. If the system isn't generating sales, the debugging isn't just looking at the webhook to see if it fired.
But they do have to check if it fired.
Sure, but it's more about looking at the analytics dashboard. Is the AI's copywriting prompt failing to convert because it's using generic robotic marketing speak?
Probably, yes.
Right. And the student has to adjust the system's parameters based on human behavioral data, not just API syntax errors. You are teaching them how to be an operator of a machine, reading the gauges and tweaking the dials.
I'm just not convinced a beginner is ready to interpret multivariate market feedback when the fundamental risk at their level is simply the AI completely misunderstanding a basic request.
It's part of the learning curve. It's a dangerous learning curve. If a student's automated customer support workflow hallucinates a completely fabricated refund policy and emails it to a client, the open rate doesn't matter. The relationship is damaged, and the financial liability is very real.
Well, yeah.
This is exactly why practical guides heavily emphasize keeping a human in the loop. You use AI to triage the inquiry, draft the response, and then, crucially, save it as a draft for the human to review.
Right.
You cut the response time from hours to minutes, but the human is still the final gatekeeper. You learn predictability in a sandbox before you launch a self-sustaining system.
Okay, look. Client-facing communications naturally carry a higher risk profile. I don't disagree that a human in the loop is necessary there. But let's look at the e-commerce print-on-demand businesses mentioned in the material.
All right.
AI tools are analyzing trending aesthetics, they're generating graphics, upscaling them, uploading them to marketplaces like Redbubble, generating the SEO descriptions, and adjusting prices dynamically.
And what happens when that breaks?
Where is the catastrophic risk? If a design workflow generates an image with 6 fingers or a bizarre aesthetic, it just doesn't sell. The market provides the correction automatically.
I suppose that's true in that specific niche.
Right. By shielding students from building these independent systems under the guise of safety, we actually just keep them trapped in the paradigm of trading time for output.
Trading time for output. See, that is the core philosophical divide here.
I think so, yeah.
Because from my perspective, the ultimate success of a beginner project is practically realizing how much of their own time they can reclaim.
Which is a small victory.
It's a huge victory. Let's say a student automates their lead qualification. They pull data from a web form, and AI scores the lead based on custom criteria and drops a summary into Slack. They just took a process that consumed an hour every day and reduced it to 0 minutes.
Sure.
The conceptual lesson there is profoundly empowering. They learn to view AI as a supportive cognitive assistant that handles the routine, freeing up their human bandwidth for deep, complex, strategic work.
Reclaiming an hour a day is a wonderful optimization. I won't deny that. But what did they actually build?
A functioning automation.
They built a highly efficient Band-Aid for a busy schedule. The ultimate success, the real paradigm shift, is realizing you can build assets that decouple your time from your output entirely. That is what digital leverage actually is.
All right, explain exactly how you define digital leverage for a beginner.
It is the shift from linear to exponential output. Look at AI-driven micro SaaS architecture. A solo developer, our student, creates a lightweight interface. A user inputs their local bakery's menu.
Okay, a basic input.
The back-end automation takes that input, feeds it into an LLM with a highly tuned system prompt regarding local SEO and engagement tactics, generates a month's worth of customized social media posts, and pipes them via API directly into a scheduling tool.
That's a lot of moving parts.
But the student charges $20 a month for access. Once integrated with payment processing and analytics, it operates autonomously. The student who builds that as their first project learns something much deeper than just time management.
They learn how hard software is to maintain.
They learn that they can be a scalable, semi-automatic machine. They aren't just saving time, they are creating net new value that scales infinitely.
Okay, I have to stop you there.
Words like infinitely and autonomously are incredibly dangerous in this field.
How so?
Because one of the biggest traps in the macro systems approach is the myth of the set and forget machine. And actually, this is something both of our source frameworks explicitly agree on. True automations are never fully set and forget.
That is absolutely true. I agree with that. The reality of the infrastructure makes that impossible.
Right. So let's talk about why systems break, specifically model drift. A student tunes a prompt meticulously. It outputs perfect JSON for 6 weeks.
And then the model updates.
Exactly. Then the provider, whether it's OpenAI, Anthropic, Google, updates the model's weights on the back end to improve safety or reasoning capabilities. Suddenly, the model's attention mechanism shifts.
It gets too chatty.
Yes. It starts appending conversational filler to its responses, or it refuses to answer certain prompts entirely due to a new safety filter. The API endpoint changes. Zapier updates its integration UI, and the required field names change. Marketplaces alter their search algorithms. The entire pipeline shatters.
That happens, yes.
You cannot maintain a complex system if you don't intimately understand the micro-components. If your automated reporting tool stops working, you need to know how to open the run history, identify exactly which node failed. Was it the webhook failing to catch the payload, the AI hallucinating a format, or the API rejecting the authentication token?
Right.
That troubleshooting requires the exact granular, task-level focus that I am advocating for. You have to know how the logic flows to fix the system.
Troubleshooting absolutely requires granular knowledge. I won't argue against that. But notice how a macro perspective completely changes the response to that failure.
In what way?
When an API changes or an AI model drifts, a student who only knows how to automate a single email might just throw their hands up and say, well, AI just isn't ready yet.
Or they just fix the mapping.
Maybe. But a student who has built a micro SaaS has a subscription base relying on that output. They have the financial and architectural motivation to open the logs, find the broken node, and implement a JSON repair loop.
Meaning a second validation pass?
Exactly. Meaning they set up a second, smaller LLM to strictly validate and clean the output before it ever hits the API. The systems thinker knows they have to periodically review and refine the architecture. The passive element only applies to the routine execution.
Okay, I see what you're saying.
The human role elevates from doing the work to maintaining the system's resilience.
So to synthesize our perspectives on how we should introduce this technology to students, my position remains that the initial foray into AI automation absolutely must be grounded in the mastery of the isolated trigger process action sequence. By tackling a single, rule-based, repetitive chore, students learn the vital mechanics of the technology. They experience the friction between probabilistic models and deterministic platforms. They learn prompt constraints, edge case testing, and dynamic field mapping. By mastering these micromechanics, they build a foundation of technical competence and risk mitigation that ensures whatever they build next is structurally sound.
And I maintain that introducing automation as mere chore reduction obscures the true power of the technology. The fundamental conceptual framework of modern AI automation is building scalable, passive systems,
Even from day one.
especially from day one, by designing an engine, whether it's an autonomous content site, a digital product pipeline, or a micro SaaS. Students experience a vital paradigm shift. They learn to move away from trading their time for a linear output and instead focus on creating independent digital assets that generate recurring value and leverage market feedback loops.
Yet we clearly find common ground in the reality of the infrastructure itself. As the source material demonstrates, AI automation is no longer just a theoretical experiment. It is a highly accessible, practical reality.
Yes, it is.
But it requires fundamentally linking distinct platforms, APIs, and language models together.
Absolutely. And whether a builder is automating a daily status update or constructing an entire e-commerce storefront, both paths demand thoughtful architectural design, rigorous manual testing, and continuous maintenance.
Right.
Nothing in AI operates indefinitely without oversight because, as we discussed, Models drift, APIs evolve, and platforms change.
For those listening, especially the students gearing up to wire their very first webhook to an LLM, there is immense value in understanding both of these paradigms.
For sure.
You need the precision of a technician to understand why a JSON payload fails, but you also need the vision of an architect to ensure you are building something worth maintaining. There is an incredible amount to explore in the source material regarding specific platforms, niche selection, and advanced API capabilities.
It really comes down to mastering the immediate mechanics while keeping your sights locked on the broader potential of digital leverage.
Exactly. So, as you sit down to connect your very first trigger to your very first action, the question remains, are you simply optimizing a single routine to save yourself 10 minutes today, or are you assembling the foundational blocks of a system that will scale tomorrow? We will leave that for you to decide.